MASW data are processed in 8 steps. Here we're going to use 3 files acquired at our field class site in Forsyth, Missouri. The first step includes data conversion from the seg2 format to internal format of the software SurfSeis. For that we open 3 files all together and we convert it into one file. The second step is assigning geometry to the file you just saved. You open the file and assign the geometry. We select active survey. We have to define the stations for the geophones, the spacing between the source and the first geophone, which was 10 feet, then 5-foot spacing between the geophones, and 3 files per location. The next step is to stack the data. We select our file with the geometry and stack 3 files we acquired at the same location. The reason we stack the data is to try to eliminate the random noise. In our case, there were people walking by the geophones, and you can see in one of the records that actually you have noise in the second half of the profile. This step is optional. You can get good results with just one file, but stacking is recommended. Step number 4 is filtering the data. It's also optional, but most of the time we have to at least mute a portion of the data above our surface waves and below our surface waves. There are other filters available, but muting is the most efficient filter in this software. Once we filtered our data, we need to select the velocity and the frequency range for the overtone image. To do that, you right-click on the overtone button and select the frequency range and the velocity range where you want to process your data. To generate the overtone image, you left-click on the overtone button and an overtone image is generated. To generate the dispersion curve, you left-click on the controls button and select the velocity range and the frequency range where you want your curve to be generated. Then you click on the extract button and the dispersion curve is generated automatically. Most of the time we have to edit it. To do that, you need to click the edit curve button, and by highlighting all the points you can remove them or just shift in the appropriate location. Then you click save button and save your dispersion curve file. Step number 7 is generating a shear wave velocity profile based on the 10-layer velocity model. You click the run button and the software automatically inverts the data and generates a 10-layer model. And check all the boxes except current and final curves. Note that our RMS should be less than 10%. If your RMS is too high or you want to modify the depth of the model, click back, View, Edit Dispersion Curves, select your file, and modify the points on the dispersion curve as necessary. Your depth of the model will depend on the lowest frequency. It's the last point on the left-hand side of your image. Save your edited dispersion curve. Run the inversion again. Now you can see that the model depth has changed from about 75 feet to about 95 feet. And here's a comparison between 2 models generated for different depth. Please note that by default there are 10 layers in the model, so you will have the same number of layers generated for a 50-foot depth profile and a 100-foot depth profile. What that means in practice, Sometimes you can get a better correlation between borehole control and resistivity data if you have a 1D shear wave velocity profile generated to a shallower depth.